The next topic that we have to talk about covers simplifying radical expressions. There's two topics about simplifying radicals. The first one will not involve variables, and the second one will involve variables. So the idea behind simplifying radicals is that sometimes a very complicated radical is actually a whole number multiple of a much simpler radical. All right, so let's look at this first example here, root 50. Okay, it turns out that the square root of 50, if you think about it long enough, you can see that the square root of 50 should actually be the square root of 25 times 2. And then, by a sort of product rule for radicals, you can break that up into root 25 times root 2. So we'll talk about this rule that we used here in a second. But after you break it up into root 25 times root 2, you see that root 25 you can actually evaluate and turn into 5. So root 50 is equivalent to 5 root 2. Okay, so the somewhat complicated radical root 50 is really just a whole number multiple of root 2. Okay, root 50 is 5 times the square root of 2. As you noticed in the last example, we really need a rule that talks about how multiplication interacts with radicals if we want to simplify radicals successfully. Okay, so the rule that tells you how multiplication interacts with radicals is the product rule for radicals. Right? And what it says is if you have the nth root of a product, you can distribute the nth root to each factor in that product. So the nth root of a times b becomes the nth root of a times the nth root of b. Alright, so let's look at a baby example to help us understand how the product rule works and how we can use it to simplify radicals. So use the product rule to simplify square root of 20. Alright, if you want to simplify square root of 20, the first thing you're going to have to do is factor 20. Okay, so I would make a factor tree. 20 breaks down into 4 times 5, and 4 breaks down into 2 times 2. And then we can't break anything else down, so these are our prime factors. 2 times 2 times 5. So the first step in simplification here is to say that root 20 equals root 2 times 2 times 5. Then our product rule is going to allow us to break up this radical into root 2 times 2 times root 5. So I distributed the square root to the first group and then to the second, 5. Why did I do this? Well, I know what the square root of 2 times 2 is. Right? Square roots take pairs of factors and turn them into a single factor. So I know that root 2 times 2 is just 2. So altogether, root 20 is 2 square roots of 5. Let's try to sum up this process here in our main idea so we can apply it to any radical expression. Alright, let's try to condense our process for simplifying radicals into the least amount of steps, okay, so that it's easier to remember as we go through the class. Right, so here's the idea. To simplify nth roots, first use a factor tree to completely factor the radicand. The radicand is the number inside the radical sign. So this is what we did first when we were simplifying root 20. We first broke it down to root 2 times 2 times 5. So that was step 1. Next, eliminate each group of n identical factors by pulling a single factor outside the radical sign for each one of those groups. So the idea is inside of this root 20 there's a root 2 times 2. And we know that the square root breaks identical factors into a single factor. So this root 2 times 2 is going to become a single 2 outside of the radical, and then we still have root 5 left. Because of the product here, there's a product between the 2 and the root 5. Okay, so the factor pulled out of the radicand will always be connected by multiplication. So that's the general process. First, factor, then look for groups of n identical factors, so either 3 identical factors or 4 identical factors depending on the type of root that you have, and eliminate each one of those groups by pulling a single representative outside of the square root or outside of the cube root, outside of the nth root.